So this video is a proof of the sine rule. Now, the beauty of the sine rule is you can work out the size of an angle in any triangle. It doesn't have to be a right angle triangle. So for right angle triangles, we could use sine, cos, or tan, depending on the information we've got. And we just go opposite of a hypotenuse or whatever the case might be. But if you have a triangle that's not right angled, you can still find a side or an angle given a pair of side and angle that are opposite each other, and if we're finding the side, we need the angle that is opposite that side. Okay, so notice, so you'll need to form an equation with only one unknown. Okay, you need to know the other three values. Okay, so why does the sine rule work? So let's start with labeling. Normally you label vertices with capital letters, and then the sides facing those vertices with lowercase letters of the same letter. So angle A is opposite side A, angle C is opposite side C, we use lowercase for sides, and angle B is opposite side B. Now, to do the proof for the sine rule, I'm going to do a height from A to the base, perpendicular height. So we're going to use trig ratios, obviously, to come up with the rule. So let's call this H for height. And what I'm going to do is find sine B and sine C, which we can now because we've got right angle triangles. And we're going to use these two answers to come up with the sine rule. So the proof will go like this. Okay. So sine B. So sine B is obviously opposite of a hypotenuse. So H on lowercase c. Okay, which then gives me a statement for H. So I'm trying to get a statement for H from both ratios, and then we'll take it from there. So then H equals C, lowercase c, side C times sine B. Now we're going to do the same for angle C. So sine C equals H on lowercase b, side B, yeah, opposite on hypotenuse, which means H is B sine C. Notice that H is B sine C, H is also C sine B. So then that means C sine B is equal to B sine C, yeah? Because they're both equal to H. So C, therefore, I'll move this a little bit. Okay, therefore, C sine angle B equals B sine angle C. Now, look, there's a quick way to do this, but I'll show you the longer way because it makes sense. So let's divide both sides by sine B, then sine C, because remember the way we wrote the rule, we had the size, the side at the top. Okay, so let's get rid of the angles. Okay, so divide both sides by sine B to begin with. Okay, so this will cancel. Then we get C equals B sine C on sine B. Now, sine B is in the denominator, which is where we want it. So for now, leave it there. Let's divide both sides by sine C in order to get rid of it. So then I'll use a different color here. So dividing by sine C, this becomes C on sine C. See, we're getting close. C on sine C and B on sine B. I just have to get rid of this. And then divide this by sine C. Okay, so we get C on sine C equals B sine C over sine B. So dividing by sine C is multiplying by its reciprocal, yes, which is 1 on sine C. So times 1 on sine C. Okay, so now, there you go, sine C over sine C cancels. We get C So C on sine C equals B on sine B. There you go. So you can repeat this process for A, I suppose, okay, for practice. And that's why the sine rule works. That's how you come up with it.